Assalamualaikum warahmatullahi wabarakatuh and good afternoon. My name is Nik Muhammad Hazim bin Alaluddin. I'm an final year student. So today I'm going to present the final year projects. The title of my project is Heat Transfer Performance of Hybrid Bioglycol in a Cooling Plate. My supervisor is Dr. Irni Azli Zakaria. For the content of the presentation, first of all, we have a project summary, introduction, problem statement, objective, literature review, scope and limitation, methodology, and expected result. For the project summary, about the project that I'm going to do and what I need to do is to study the characteristic of the bioglycol in a cooling plate of PMFC, the study on potential cooling plate fluid, improvement of proton exchange membrane fluid cell. The improvement will incorporate nanoparticle to the base fluid of the bioglycol, which is believed to improve the heat transfer significantly. Bioglycol is adopted since conventional ethylene glycol is toxic and hazardous to humans. Studies will be done by using numerical method to show the performance of the plate of PEMFC. For introductions, with the new global development and economy leads to dramatically increase for the green energy demand, the proton exchange membrane fuel cell PMFC is taken into consideration to be maximum promising power conversion device. PMFC is significantly worried with its benefit excessive electricity, density, low emission, and rapid reactions. However, the cost of the industry software development of PMFC, the power swift, efficiency, reliability, and steadiness are nevertheless needed to be improved. For the problem statement, during the operation of PMFC, a lot of heat have been generated due to the chemical reaction to prevent the overheating. In order to improve the consistency and longevity of PMFC, uniform temperature dissemination and low temperature change are required. Objective: to design an alternate cooling plate designed for the PMFC. Second one is to investigate the performance of hybrid nanofluid in bioglycol in the cooling plate of PMFC in terms of heat transfer and pressure drop. Next, let's move to the literature review. For the PMFC first, number one is experimental investigation of Al2O3 water ethyl glycol mixture of nanofluid thermal behavior in a single cooling plate of PMFC application. Year of the published is 2015. The finding from the last previous study is show that the enhancement in the heat transfer performance with Al2O3 in 50-50 water ethyl glycol as compared to the base fluid of water. Second one is a liquid cooling technique in proton exchange membrane fuel cell stack, detailed survey. The finding is nanofluid use coolant to improve not only the heat transfer characteristic of PMSC heat exchange, but also decrease the front error use from 20% to 27%. Third one is a numerical study of a MIMO-shaped cooling plate of PMSC stack for heat transfer enhancements. The MIMO field can improve the cooling performance of PEMFC. The Z-shaped flow field show better cooling performance than U-shaped design. The maximum temperature can be reduced to 320.7 Kelvin. The fourth one is thermophysical properties of silicon dioxide SiO2 in ethylene glycol water mixture for proton exchange membrane fuel cell. The enhanced thermal conductivity can be obtained by dispersing high concentration of nanoparticle. To limit the its increase, Eg was mixed with the water-based fluid, but the viscosity of the nanofluid increased with Eg concentration. Next, for the PMFC cooling plate design, The numerical study of the MIMO shape cooling plate in the PMFC stack. The MIMO flow field can improve the cooling performance of PMFC. Z flow shape flow field show better cooling, and the maximum temperature can be reduced to 322.7 Kelvin. Second one is analysis of heat transfer on film cooling performance in a flat plate. The overall average convection heat transfer coefficient on inner wall of the film hole decrease with the increasing of line diameter ratio, increase with the increase of blowing ratio and the film cooling hole angle. Third one is a numerical analysis of aluminum oxide and silicon dioxide nanofluid in separating cooling plate of PMFC. Enhancement is due to the superior thermal conductivity of both Al2O3 and SiO2 nanofluid as compared to the base fluid of water. For the nanofluid, the thermal enhancement in cooling using the novel hybrid nanoparticle with mass transport. The advanced method of dispersion of a nanofluid particle into the working fluid, Newtonian or non-Newtonian, is introduced to prevent overheating in many applications. For example, solar cell, electronic cooling, and automotive cooling system. Heat transfer and a pressure drop performance of nanofluids, state-of-the-art review. The nanoparticle with optimal size and concentration improve the thermal performance of heat exchanger. Particles with a higher volume fraction and size lead to the lower thermal hydraulic performance by increasing the value of pressure drop and pumping power, since the variation in viscosity of nanofluid is directly associated with the volumetric concentration of nanoparticle. The third one is electrothermal characteristic of hybrid TiO2, SiO2 nanofluid coolant in the electrical active system. The preliminary test using the water, ethylene glycol, and 1% volumetric of TiO2, SiO2 50:50 ratio in a 60:40 ratio of water ethylene glycol. Base fluid were conducted using a varying Reynolds number between 300 to 700 at temperature 60 degrees and 70 degrees Celsius. The fourth one is enhancing thermal conductivity of fluid with a nanoparticle. The finding is one of the benefits of nanofluid will be dramatically reduced in heat exchanger. Nanoparticle based fluid can double the rate of the heat transfer. For the Bioglycol, the thermal analysis of heat transfer enhanced and fluid flow of Al2O3 water ethylene glycol nanofluid in single PMFC mini channel. The finding is the heat transfer and the pressure drop characteristic for the laminar flow of 0.1, 0.3 and 0.5% of volume concentration of Al2O3 in 60:40 ratio water to ethylene glycol in single carbon graphite mini channel has been analyzed. The heat transfer coefficient increased by 80.11%, 9.86% and 5.37% for 0.5, 0.3 and 0.1 volume percentage concentration Al2O3 in 60:40 water ethylene glycol consecutively at Reynolds number 140. The third one is a forced convection, heat transfer, and friction factor of the water bioglycol mixture based TiO2, SiO2 nanofluid. The set number of the nanofluid increased with particle concentration and Reynolds number, where the highest Nusselt number was observed at a volume percentage which is 70.11%, higher than base fluid. Small additional of nanoparticle led to a great heat transfer enhancement. Average enhancement for 0.5%, 1.0% and 1.5% are 43.3%, 63.4% and 70.3% respectively. At higher Reynolds number, maximum 60.9% heat transfer coefficient argumentally was observed at 1.5 volumetric percent. Friction factor of the TiO2 and SiO2 nanofluid decreased as the Reynolds number increased. Dispersion of TiO2 and SiO2 in a mixture of water and bioglycol did not significantly influence the frictions. The fourth one is experimental investigation and development of a new correlation for thermoconductivity and viscosity of bioglycol, water-based SiO2 nanofluid. The maximum viscosity enhancement was observed for 30 to 70% ratio bioglycol water nanofluid, about 1.38 times in the volume concentration of 2.0% at 70 degree. Nonlinear correlation have been proposed with a 3% maximum deviation for the estimation of thermal conductivity and viscosity of nanofluid. 5. An experiment determining the thermal conductivity and electrical conduction of a bioglycol-based or Al2O3 nanofluid and development of a new correlation. The findings show that the increment in temperature reacts inversely to the thermoelectrical conductivity ratio. Maximum value of TEC is 9.5% at 0.5% volume concentration and temperature at 30 degrees Celsius. 6. Stability and thermophysical properties of a green bioglycol-based TiO2 SiO2 nanofluid. The thermal conductivity of the green bioglycol-based TiO2 SiO2 nanofluid were enhanced up to 12.52% higher than the mixture of the water bioglycol at 3% volume concentration and temperature at 70 degrees Celsius. Meanwhile, there is a significant dynamic viscosity increment of the green bioglycol based TiO2 SiO2 nanofluid with temperature. Next, for the scope and limitation of the project, this study was conducted in a field of the thermodynamic and energy studies. The scope will be covered in the study is by assuming the laminar flow and that was in a steady state. And also the nanofluid will be considered as a single phase, and the study will be conducted through the numerical analysis. For the methodology, this is how the project is going to run for the whole FYP project. First one is to define the research problem. Next is a literature review. Formulate the research questions. Develop the research conceptual design. CAD generation, meshing, run simulation, validate with the actual. If the result is okay, then we are going to proceed with the next simulation. If the result is not okay, going to meshing it again until it's validate with the actual. And next, we are going to make a data analysis, and finally, we are finding the discussions. For the development conceptual design, I'm using the SolidWorks 2020 software to create the model of the cooling plate, and also running a simulation through the NC software. And below is the picture of the model of the cooling plate have been made using the SolidWorks 2020 software. The next is a table properties of the nanofluid and base fluid that will be used through the research. First one is the nanofluid particle base. We have SiO2. The thermal conductivity is 1.38. The electrical conductivity is 10 power of negative 21. The density 2200. For the distilled water, we got the thermal conductivity of 0.61615. For electrical conductivity, we have 6, and density is 999. Lastly, for the water and ethyl glycol, the thermal conductivity is 0.252, electrical conductivity is 1.07, and the density is 38. For the expecting result, based from the previous study, there is a picture for the table with various result. First of all is a Nusselt number against the Reynolds number, the pumping power against the Reynolds number, and a heat strength coefficient, and also the plate temperature against Reynolds number. The nanofluid in a 60 to 40 ratio water ethyl glycol show a better result in the observation. The Reynolds number also affecting the result. The volume percentage of concentration of nanofluid in a base fluid make a significant difference in the final result. That's all from me. Thank you for spending your time listening to my presentations. Thank you so much.